Okay, in a previous lesson, we talked about ions and we said that when atoms lose electrons, they become ions, or when they gain electrons, they become ions. Basically, we're messing with the charge. And we said that on our periodic table here, there's actually a few groups that we can predict how many electrons are going to get lost or gained. For example, group 1 here, we could say they form a 1 positive charge because every atom in here minus hydrogen doesn't really, it only applies to the metals. Every metal in here loses 1 electron in group 1. And we said the same thing about group 2. 2 positive charge here because every metal in group 2 forms a 2 positive charge. Group 13 is a 3 positive. Every metal in group 13 forms a 3 positive charge. We said the same thing for nonmetals too. We said we can predict some nonmetals. So group 17, 1 minus charge here for group 17, 2 minus charge for group 16, and a 3 minus charge here for group 15. So we're going to use the fact that we know these charges to predict what formula, what compound forms between two ions. So for example, let's say I have sodium and I have chlorine. Both of them are going to become ions, and both of them are going to get together and make a compound, make an ionic compound. So for sodium, we know sodium exists in group 1 over here, so its charge is 1 plus. And we know chlorine exists in group 17 over here, so we know its charge is 1 minus, just like this. And the way I'm going to show these is that for a 1 positive charge, I'm going to put a plus sign in a circle to represent a 1 positive charge. For chlorine, I'm going to put a minus sign in a circle to represent a 1 negative charge here. And what we're looking for when we pair these things up is a net charge, so all the positives to balance out the negatives. We want the net charge to equal 0. That's what we're looking for. And it turns out that that's exactly what's happening here, right? My 1 positive charge is balancing out my 1 negative charge, and I have a net charge of 0. So my formula here is just going to be Na with an invisible 1 right here, and then Cl with another invisible 1 because it takes 1 of each to balance this out. 1 of each. Okay? Let's do something a little bit more complicated. How about calcium, Ca, pairing up with chlorine, Cl? Uh, we'll look up the charges for these. Chlorine's pretty easy because we have it from the previous problem. Chlorine is 1 minus, we know that. Calcium is in group 2 over here. So calcium takes a 2 positive charge. And again, I'm going to represent these charges as little symbols in circles here. So a 2 positive charge would be 2 positive charges in circles there. A 1 minus charge would be 1 minus charge in a circle right there. And just like our previous problem, we need this whole thing to equal 0, and it does not. Right? It does not. So we have 2 positive charges, which is more than the 1 negative charges. So what we need to do is add more negative charges. And we can't just add another negative charge and call it a day. We have to actually add an entire new chlorine anion, chlorine negative ion here. So I'm going to try to squeeze one in here. Let's put it right here. We'll add another chlorine with a 1 minus charge. 1 minus charge. And put another little negative sign down there. So now I have 2 chlorines balancing out my 1 calcium. 2 positive charges, 2 negative charges. My total charge here is 0, and now I have my formula. So it is Ca with a 1, because there's only one Ca up here, and then Cl with a 2, because it took 2 Cls to do this. Okay, let's put one more complicated one here. We have a little bit of time. How about aluminum getting together with sulfur? Aluminum getting together with sulfur. We look up the charges. Aluminum has a 3 positive charge, which means it has 3 positive charges to get rid of, to balance out. Sulfur has a 2 negative charge, which means it has 2 negative charges to balance out. And right away you can see our problem, right? We want this to equal 0, and you can go back and forth on this, right? You can say, okay, well, I need more negative charges, so I need to add another sulfur in here, which brings me to 4 negatives. And then I need to add another aluminum, and it brings me to 6 positives. So you can go back and forth and solve this problem. This is as complicated as these problems get. Or you can do the trick. right? We have a trick for this. It turns out we do. Our trick for this, if you have two ions that you're trying to get together and you know the charges of both ions, what we can do is we can do what's called crossing charges. So we can say cross charges, and then if you do this trick, cross charges and simplify. Okay, so for example, we have aluminum 3 plus and sulfur 2 minus here. What we can do is we can say, all right, well, let's just take the charges here, just the numbers of the charges. I'm not going to take the plus and the minus, just the numbers. And let's cross them up. Let's make them subscripts. So we'll take the 2, we'll throw it over here. We'll take the 3, I'll put it over here. And we turn them into subscripts. So the formula when aluminum and sulfur get together is going to be Al with the charge of sulfur as its subscript. So this 2 comes down here for aluminum. And then sulfur is going to take the charge of aluminum as its subscript. So 3 down here. And this is the answer. We could have done it the long way, where you add a sulfur and then add an aluminum and do it all that way. Or you could just do it with the little tricky route here. We're just taking the charges and crossing them up and making the formulas here. And we could have done that up here as well. The 1 cross up here, we have NaCl, right? The 1 and the 1 cross here, and we have NaCl. Same thing up here, right? My charges, my 2 and the 1, they cross up just like before, and we end up having Ca1, Cl2. All right? So it's an easy way to figure out what compounds form when two ions get together.